Okay, we are continuing with the state graph of BCD to XS3 code converter using sequential circuit. So we have the graph here which was drawn in detail using the truth table of BCD to XS3. Now what we have to observe is how we can reduce this graph. So this is explicit detailed graph. We need to see how to reduce. So what you can see here is D is little different from this EFG. D has outgoing arrows as 0, 0 and 1, 1, which is different than all these outgoing arrows. But if you see EFG, you can see it has similar outgoing arrows of 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. So in the first place, what I understand that EFG can be replaced as a single state only. So I am planning to choose E. So F will be made equal to E and G will also be made equal to E. So I will be reducing two number of states and I will be having three states here. I will be having three states equal to one state here. So this is number one reduction. Please make a note in your notebook. You write E is equal to F is equal to G and we are using state E for our further purposes. Okay. So this is one thing. Now next I want you to observe in the next row, that is after T2 row. Now you observe here which all are similar. You should be able to see on your own which all are similar to each other. So now you check carefully about H and you can take any other H and I. Can you see H and I? H outgoing is 0, 0, 1, 1. I outgoing is also 0, 0 and 1, 1. So what you can see, H and I can be denoted with one same state. Of course, incoming arrows will be taken care. When I draw the reduced state graph, you will observe that time. But now you understand the conditions based on which we reduce the graph. So H and I are same. You can see here properly. H and I are same. Now see further, your H and I both have one outgoing arrow of 0 and 0, 0, 0. So what you can see, this L, this J, that also has 0 and 0, right? So H, L, J, I, all are same. It can be used with one state only. Let us see further. You have this 1, 1. Okay, we do not have any other 1, 1. Now you have to write in your notebook. You write now H is equal to L. Why? Because 0, 0 outgoing is same. H is also equal to J because 0, 0 outgoing is same. N is not same. Okay, N is not same. Let us go further. I is equal to H because it has same outgoing 0, 0 and 1, 1. Then your M is again not same. So let us leave it for the time being. Coming on to K. K is same because it also has 0, 0 which was there in this. So what you see? You see that H is equal to IJKL. So HIJKL, all these can be replaced by only one state. So I am using H for it. HIJKL, these 5 states can be replaced by one state only. So after that, let us see what is remaining. What is remaining is M, N and P. So you see this N has 0, 1. What is M? M is also having this 0, 1. And what is P? P is also having 0, 1. So you can see that M, N and P can be, again, it can be made equal. So observing this state graph, what we have analyzed, we analyzed 3 equalities. Number 1 was E, F, G are same. We will be using E for this. Number 2, H, I, J, K, L are same. We will be using H for that. Number 3 is M, N, P are same. We will be using M for that. So these 3 conditions we have understood. Now we need to know with these 3 conditions how to carry on making your state graph. how to carry on making your reduced state graph. Okay, now I am not able to append on this sheet only. I will have to use a fresh sheet, but you have this with you. You refer that and then follow what I am doing. Okay, so let us start with the reduced graph now. Any doubt in the equality what I have explained you people? So now we have to do today's is module. Today is module 5 class 4. This is continuation of yesterday's work, that is BCD to XS3 code converter. What we are doing today is reduced state graph. Reduced state graph of BCD to XS3 code converter. You people have to be very observant and careful to understand this. As I told you already, this is something which is asked several times in the exam. You can't mug up this, you will have to understand. Okay, so what you see, there is no change in the first part. I am copying whatever we did yesterday. Okay, I will see if I can keep the other one beside so that it is easy for you people to okay. So now you people can see it very carefully. What you can see, A to BC, there was a no problem. Now D also, there is, we are keeping this D state. So you see what is happening left and right. D from B, D is going without any change, no, nothing, same to same, I'm copying. Now, E, F, G is the same state. So I am bringing E here. Now, B to F, whatever was going, now it will go B to E. So I have to mark the same. There should not be any change for my reduction, right? Now, from C to E, it should go the way it was going before also, C to E, and this is 0 and 0, right? Now your G is also equal to E. G is also equal to E. You can see here, G is also equal to E. So C to E with the condition of 0, 0, C to E again with another condition, that is 1 and 1. I hope you people are understanding this. So state remains same, but the arrows are coming to E from B and C with the three conditions. And C to E, the condition is 0 and 0 and 1 and 1. I am not doing any alteration. It is still the same. And what is this doing is, this is making E equal to F equal to G. This is what I have depicted here. Next, I told in the discussions that I will have a H. Now let me see. And what all I have done is H is equal to I equal to J equal to K equal to L. Now I have to do all these things in the graph now. Now you check this H. So D to H is coming without any problem and it is 0 and 0. So there is no change. Now you have to see next L. L is equal. Can you see here? L is equal. So it will come from D to L and L is replaced by H, and this 1 1 condition will also come here only. So 1 1 condition will also come here. So H and L is made same. H and L is made same. Next, coming to J. J is also coming in the same line. So, but it is coming from F. What is new F? New F is E. So what will happen? From E to H it will come like this, and you will have your condition of 0 and 1. You will have your condition. So what did I do? Instead of F to J, it went from E to H, because now F is equal to E and J is equal to H. I hope you people are understanding. Please understand carefully and do it along with me. So H over L over J over, right? Now, next I have to see N. N is a different story. So N is equal to, another condition what we had seen was M is equal to N is equal to P. So I will put M here. I will put M here. I'm going in order, okay? So N is equal to M now. N is equal to M from EF, that is now E. From instead of F to N, it will go from E to M now. And what it is 1 and 0. Okay, it is 1 and 0. Next, I is equal to what? I is equal to H. And what is the condition? Condition is 0 and 1. Condition is 0 and 1. So do you think we have already finished it? E to I is now E to H with the condition 0 and 1. And you can see this is already over, 0 and 1. Now come to M. Coming to M, it is E to M with 1 and 0. And you can see that is already over because it was copy paste, na? It is already over. E to M is already over. Now coming to K. K is G to K. Now what is G? New G. New G is E. And what is new K? New K is H. So what I want E to H with the condition 0 to 1. And you can see that is also already over. E to H with 0, 1. It's already over. That is why these are all similar, no? Next, P. P says P is equal to M now. So, and G is equal to E now. So, E to M with 1, 0. So, you can see already it is over. E to M with 1, 0. So, so many state changes have been replaced by this. And with observation of the extended state graph, when we observe all this, we understand that so many states can be reduced. Now, next job is to do this T3 change. T3 change. Now, you have to be very careful to understand this again. Now, what do you see? H. From H, it is going back to A with the condition of 0, 0 as well as 1, 1. So, what I will do? I will do the same thing again. H to A, and what is the condition? 0, 0 and 1, 1. Same thing is happening, no? I hope you are understanding. 0, 0 and 1, 1. From H to A it went. Now, what about L? L is equal to H only, and 0, 0. This one is already taken care, right? L to A, 0, 0 is already done. H to A, 0, 0 already done. Again, J to A is nothing but H to A already done. No need to repeat. Coming to N now. N is equal to M. N is equal to M now. And from M, what is the condition? 0 and 1. 0 and 1 from N to A. And N is now M. So I need to show that. I need to show this one, right? And this is what? 0 and 1. 0 and 1. Done? So I have finished my N. N 0 to 0 and 1. Coming to I. I is H now. And H is going 0, 0 and 1, 1. That is already done. 0, 0 and 1, 1 is already done. So finished. I was already equal to H. Now M is 0 and 1. Already it is there. Then K is 0 and 0. Already it is there. See my mouse. Then P is 0 and 1. P is nothing but M now, and it is already there. So this state graph is reduced to this now. I hope you are able to understand what I am saying. The state graph is reduced to such a small one. Now, how many states I have here? I have 7 states. So 7 states means I require 3 flip-flop. I require 3 flip-flop. So now next I should reduce my previous big state table to the small one now. So quickly I will do it here. I will do it quickly so that it completes. So your present state, then your next state. Under next state, you have two condition, that is x equal to 0 and x equal to 1, two conditions, and your output which is z, that also has two condition, x is equal to 0 and x equal to 1. Actually speaking, you had seen the extended state table yesterday. That extended state table is reduced to this because your state graph also reduced. But quickly to complete, I will do it. So present state A, when x is 0, it is going to B and output is 1. I hope you know to read. From A to B it is going, x is 0, output is 1. Left hand side of slash is x and right hand side is z. So when x is equal to 0, A to B state is changing and output is 1. So when x is equal to 0, A to B state is changing and output is 1. Same way, when x is equal to 1, state is changing to C and output is 0. So the same way we are completing it. I will not spend more time here because you are already aware of this. Now instead of F and G, I will be writing E only here. And you will see, because the input and output were same, I am able to get my Z correct. I will open the corresponding big table also so that you can relate to what we are doing. Now your I, J, K, L and H was same, made H. So that is why so many H will be seen here. You can also see from E, it is going to M also. So M is coming here and your state is changing, the output is changing like this for your T2. Whatever I am doing can be seen in the graph also, state graph, right? Now T3 is state H and M and all are going back to A. But there is no state for x equal to 1. There is no state for x equal to 1 and output being also 1. So input 1 is there. This is input 0, output also 0. This one is input 1, output also 1. So, input 1, output also 1. And this is the case when input is 0, output is 1. And this is the case which is not available. When x is equal to 1, output is also 1 is not available. So, this is the case when m is not going to the next state. So there were only three conditions. You can see here, na? There were only three conditions: 0 and 0, 1 and 1, and 0 and 1. There was no condition of from M to go to A with 1 and 1. So that is why this is a dash here. So this makes your state table. Next important thing what you have to do is state assignment. If you remember, in previous state table cases, what you had seen, you were randomly taking care of your state assignment, right? Then you will have to observe that here it will not be so random. You have to do some work for that also. Why I am saying this is because you know that H and M is changing to A. So these state assignment should be adjacent to each other. For example, I will make the table here. You will understand what I am trying to say. If I call this as Q1, Q2, Q3, your state assignment should be adjacent to each other Otherwise it will be a problem and your equations will come very much complicated. So if I am calling this as, this is this is called as assignment map. Whatever I am doing now is called as assignment map. You copy down in the same name, assignment map. Now this is assigning the state variable to these states. You know, because I have 7 state, I will require 3 variable. So I can give 0 0 0 to A or M or E or D, anything. But we have to observe that A, B, E, M. You can see now there is a change here, A, B, E, M. So this A, B, E, M should be adjacent to each other. So that is why what I will do, I will put and A and B here, right? And I will put E here, M here. Do you think that these are adjacent to each other? Yes? These cells are...
Can you repeat?
I am saying that because I can see in this state graph, there is a change of A, B, E, M like this. I will have to see that somehow something should be adjacent to each other. So this is done only to make sure that when you make your final state machine, the equation does not become very complicated. Okay. So when I see M should be adjacent to A. Why? Because change from M to A is happening. So that is why I kept my M here adjacent to A. Now my question is, do you think that this cell and this cell are adjacent to each other? A and M cell? Is it adjacent to each other in terms of variable? You people have forgot your K map. These two cells are adjacent to each other if we fold this map. So A and M are adjacent to each other. B and E are adjacent to each other. Why this is important? Because there is a state change from M to A. There is a state change from B to E. That is why it is important to keep like this. Now, after E, what is the other state change happening? What is the other state change happening? It is going to H, right? So also you see that from H it is going to A. So that is why here H and A is fine. Please write carefully. This is M. Okay, this is M. One H is also there. No. Now I need to see that H and M. H and M are here. And your C and D I need to search now. C and D. So after B, D is coming. After C, E is coming. Right? So now I will put things here and let us see how it is going on. If I put C here, if I put D here, and if I put H here, you should see that there is only one variable change happening between the adjacent thing. So that is why I have kept here, I have kept C here, and you people write one line that to simplify the output function states A, B, E, M and C, D and H should be given adjacent assignment. Of course, if you don't give like this, then also the answer will come. But the only thing is your output function equation will be little complicated. But answer you will get. That is not a problem. Okay. So you make a note. I will explain it further. You make a note of it. Next, what you will get is, you should put your A as 0, 0, 0 now. B as 1, 0, 0. I hope you are understanding what I am saying. A state will be named as 0, 0, 0. B state will be named as 1, 0, 0. C state will be named as 1, 0, 1. So this is the state assignment which we need to follow. Okay. Now I will use my next page. Quickly we need to do this because this is something which you have already done. Just to complete things, I am writing it here. You are supposed to do it on your own. Q1 plus, Q2 plus, Q3 plus, this is your next state. And for x equal to 0 and x equal to 1, then this is your next state, this is your output, that is nothing but z. Again, this is also for x equal to 0 and x equal to 1. Okay. Now, because I have written my states at A, B, you need to dictate this to me. Okay. So what is A named there? A is a 0, 0, 0. And what is B? What is B here? B is 1, 0, 0. B is 1, 0, 0. Can you see? And what is C? C is 1, 0, 1. So this is what we are using. Okay. So B is 1, 0, 0. C is 1, 0, 1. So it is being copied from our state assignment. Okay. E is 1, 1, 0. You have that in front of you. Use that to verify that what I am doing is right or not. Okay, this is there. Next, something is there which is not being used. And what is that? That is a dash. And this 0, 0, 1 is not being used. But still I write here because I need to write don't cares for that. Now, next what you have to see in this is from A, present state A, it is going to B and C. So B is 100, C is 101. So I have to copy that only. 100 and 101. So I hope you people will be able to do this on your own. I am simply writing to make it complete. You have to observe and solve it on your own. Okay. So what is the next step? Anybody can tell me? What is the next step? I'm waiting for the answer.
K-map.
K-map of Q1 plus in terms of X, Q1, Q2, Q3, right? And same way Q2 plus and all. Now, one thing I want you people to see here is wherever you have, you see, after M, it went to A, that was 0, 0, 0. And then it was a dash. Dash means it will be a don't care, right? Next, because I do not have one of the cell in the assignment map that will have left and right all as don't care. So here I will have a don't care because from M one place it was not going. And when I have the other one that is 001, it will go to don't care only. Okay. I'm copying it because I have the answer with me. So it is 1, 1. You can always keep both the tables next to you and do this on your own. In exam anyway, you will be following these steps. So this is my state transition table. Next, as one of you have told me, you have to write 3 equations, Q1, Q2, Q3 plus as a function of X, Q1, Q2, Q3. Okay. Next, I will show you in the text that when we are getting it. Okay, let us do one K map here just for the sake of completeness. I want you people to do one K map at least with me. By that time, I will open the final circuit from the text. So I want you people to do for D1. You know, no, I told in the beginning of this lecture that we will be using D flip-flop. So D flip-flop means you do not need to write it again. You all know that D1 will be equal to Q1 plus. Now I want this K-map from you people. Quickly. You people can do, or you need my help to explain this again? No answer means what should I expect? Of course, in the book it is in other order, but we have been doing in this order, so we will use this only. Answer will come anyway, same only. I hope you people are following. Okay, now how to fill this? You have Q1 plus column. Which is Q1 plus column? This is your Q1 plus column. This is your Q2 plus, this is your Q3 plus, right? Here also this one is your Q1 plus, Q2 plus, Q3 plus, right? Now I have to observe Q1 plus column. When I observe Q1 plus column, I can see that these three are ones. And what is this three? X is your MSB here. So I have to take 0, 0, 0, 0. So it is a 0. Next, 0, 1, 0, 0. So what it is? 0, 1, 0, 0?
4.
4, right. So I will have to write 0 here for 1 for 0, for 4 also 0. What is this one? It is a 0, 1, 0, 1. Yes, what it is?
5.
5, right. So from this column, I got these ones. I should make this don't care also, because this will use to simplify my equation. So it is what? 0, 0, 0, 1. So it is a 1. I am putting a don't care here. Next, in this column also, I can see that there are 3 ones. So what is it? 1 triple 0 means 8. Then 1, 1, 0, 0 is a 12. So I need to put at 8. I need to put at 12. Next is what? This one. So it is what? 1101. What is 1101? 1101 is a 13. 1101 is a 13. So I am putting here. Next is what? Your 2 don't cares. So I need to read that also. So it is 1010. That is 10. Why I am saying 1010? Because x is equal to 1 here. So 1010 is a 10, and last one is 1001 is a 9. So 10 will have a don't care and 9 will have a don't care. So this is complete. Now what I have to do? I have to group it. So if you group it, this complete thing is coming. And what it is equal to? I need to write here now. This one was 0, 0, 0, 1, 1, 1, 1, 0. Same way you have to write here. So what it is? What is D1 equal to Q1 plus equal to?
Q2.
Q2.
Bar. Q2 bar.
Q2 bar. So you can see Q2 bar is not changing. Q3 is changing. And here X and Q1 are all changing. So it is a Q2 bar. So I got my equation for D1. In the same fashion, you will be making the equation of D2 and D3. You will get the equation for D1, D2, D3 like this, and one more you will get for Z, right? So next what you will do is, I will open the text so that we can see the circuit. Yes, are you able to see the book?
Yes, ma'am.
Okay, we will come to the place from where we are doing it. This is your code converter. We saw this yesterday. Now we have, this was your unreduced state table. And you can see that how we have change this IHIJKLM to H, and that is how we have got reduced table. This is what we have done now. Next, they have not given reduced state graph. Of course, I have given now. This is your transition table. These are your, this is what you have found out on your own now. D1 equal to Q2 dash. They are following different nomenclature, keeping MSB X here and LSB is here. You do how you have been doing from beginning, but equation will come same, do not bother. So this is the circuit how we are getting. You have your D1, D2, D3. So what you have found out just now was D1. D1 equal to Q2 dash. So this is your D1. D1 is equal to Q2 dash. D2 is coming equal to Q1. D3 is coming little big. You can see here. D3 is coming little big. So D3 is being connected with your gates here. Clock is there, of course. And Z. Z also is equal to this equation, and that is found. So this is your code converter circuit using the D flip-flop. I would like to add in this, if you get in exam that make the state machine for BCD to XS3 code converter, you will have to do all this what I have explained you just now. But if a question comes that make the state, make the code converter circuit using ROM, then what will happen? I am bringing this here. This is design of sequential circuit using ROMs and PLA. Now using ROMs and PLA, there is no worry. You can see you have your same state transition table here. This is your truth table. Okay. This is the truth table which is made by expanding your state transition table. Okay. I will explain you how that has happened. See here. The only thing what is done here is observe it carefully. What is happening? Your X equal to 0 is brought here, no? X equal to 0. Your X equal to 0 is brought here because that is part of input. Okay? X equal to 0 is brought here, and your Z output for X equal to 0 is brought here. Can you see? 1100 Here also 1100 So this table was keeping X equal to 0 and X equal to 1 in 2 columns. Here it is brought in 1 column only. This table and this table is same. Why we bring in this form is because we want to show it as the input and output of the ROM. That is why we are bringing it in this form. So what you can see here, X equal to 0, keeping all 0 here, and all these conditions 0, 0, 0, 0, 0, 1 and all these conditions are copied here. Can you see? It is copied here. One condition you are not having, that is was your 7. So that is why that is also kept here with a don't care. And this 100 is starting again from here. X equal to 1 and 000 here. X equal to 1 and 001 here. So you can see X equal to 1 and 001 here. So this table and this table is same. And your Z, this column is coming first here. And I don't care because of this 7. And this column comes next. Can you see? This column is coming next. So this becomes the truth table for your ROM. Okay. So you should be able to keep it in this form. Then what happens further? How do we show the connection? Sorry. See here what is happening. You have D flip-flops here, and simply it is showing that Q1, Q2, Q3 plus and Z are the output, and your the feedback of Q1, Q2, Q3 and X is your input. So this is called realizing the same code converter using ROM. Okay. So do not get confused that it has become complicated. It is realizing the same code converter using ROM. Same state transition table is coming, but it is just kept in a form saying that it has input of, what is the input? Input of X, Q1, Q2, Q3, and output of Z, D1, D2, D3. So you can see ROM output D1, D2, D3 is coming from this. It is coming from this, and ROM input of X and this Q1, Q2, Q3 is fed back like this. So you get your 4 output of Z, D1, D2, D3 from the ROM and the input. So when you give this, this will be burnt into this ROM. That is 16 word into 4 bit. Why 16 word into 4 bit? Because these are 4 bits and 16 rows. That is why it is called as 16 words into 4 bit. So this is called implementation of code converter circuit using ROM. Now the same code converter circuit, if I want to use the PLA, which you have done already in your module 2. These are your equations, D1, D2, D3 and Z. This is the equation which you have got from the state transition table and K-maps. D1 equal to Q2 dash we did in the class just now, and others also if you do, you will get it. This is your PLA table which you have seen before also. I will explain it once again. What you can see here is D1 is equal to Q2 dash. So what is happening? D1 column, this row, only D1 is equal to 1. And what is the input? Q2 equal to 0. So this first row is dedicated to D1 equal to Q2 dash, because D1 is high here and Q2 is 0 here because it was a Q2 dash. So making D1 1 here, Q2 0 here, I am establishing the PLA connection. Next, coming to D2. D2 is equal to Q1. So D2 is 1 here and Q1 is 1 here. So this is done, right? Coming to D3. Now D3 has 3 terms. Can you see? D3 has 3 terms. So in D3 column, you will have 3 ones because it had 3 terms. Now this first one is what? Q1, Q2, Q3. So this one done. Next one is what? Q1, Q3 dash. So Q1, Q3 dash and X dash is also there. So X dash, Q1, Q3 dash. And what is the last one? Last one is X, Q1 dash, Q2 dash. So it is X, Q1 dash, Q2 dash. Same way, this is called as PLA table. Okay. Any doubt? This is your PLA table. So if we say that I want to implement this code converter circuit using PLA, you need to make this PLA table, and then how you will show? You will show the connection something like this. I hope you remember this. This is one of the example. One example, it is just trying to show that how D becomes equal to this. And how do we do this? This is your OR gate, which is doing this OR, this OR. I am saying all this fast because we have done this in module 2 actually. Okay. But it is again coming here with the code converter circuit. So this plus is done by this OR. You have 2 AND terms. So 2 AND are coming here. And how it is fused? This is A bar, B, Q bar. So A bar is fused, B is fused. You can see this heavy dot with a cross, no? B is fused and Q dash is fused. So A bar, B, Q bar is fused. So this line is there for this first term. This line is there for this second term. So this shows only 1D. So if in exam you get that implement the code converter circuit using the PAL, you are supposed to make this type of circuit. Here they have shown only for 1D flip-flop. Like this, you will have 2 more flip-flop, right? You will have 2 more flip-flop. And you can also see how your Q and Q bar is going as the feedback here. So only one segment of the sequential PAL they have shown. You should be aware of this also. So this is your third topic under your module 5. Okay. So I hope this is clear to you. If required, you can see the video again. but make this clear with all of you.